Hello everybody, so we're going to talk today about the trapezoidal rule. Now, the term trapezoidal just means related to trapeze, which is the shape that has two parallel sides. Um, so if you tried to find the trapezoidal rule in your log tables, it will look just like this. It's on page 13 of the log tables. So you see a shape that looks like this. It's flat on one side and then there's a curve on the other side. And the trapezoidal rule then just says that to get the area of that shape, it will approximately be equal to h over 2 times y1 plus yn plus 2 times y2, y3, y4, etc. So just to talk you through what this actually means. A is the area, h is the distance in between each of these segments on the curve. Y1 is the height of the first line coming up to meet the curve. Yn is the height of the last line. Y2, y3, y4 are just all the in-between ones. And yn minus 1 would be the second last one. So if we had 10 different lines coming up, then yn would be y10 and yn minus 1 would be y9. So the second last one before the last one here. So we can have a look now at how to actually use this formula. So we'll take the formula with us. And we'll have a go at actually solving a question. So we could be given a shape that looks like this. And we could be asked to find the area of this shape. So what the trapezoidal rule is really just saying is that it's a good strategy to divide this up into multiple smaller sections. All of these sections need to be equal in length. And basically the way the trapezoidal rule works is that we are essentially dividing it up into a bunch of smaller trapeziums and getting the area of each of these trapeziums. Now, as you can see, that doesn't exactly match the area of the curve, but it is a pretty good way to approximate it. So now we can have a look at using this formula here. So let's say that the distance in between each of these was 6 centimeters. And then we have the different heights as well. So the first height we could say is 4, then this one might be 6, then 8, then 7, then 5, and then another 8 here at the end. So we're going to try and fill all this into the formula. So we'll just write it out again. First of all, area, remember the squiggly brackets mean, is approximately equal to y1 plus yn, which is the first height and the last height, plus 2 times y2, y3, and so on to the second last one. And then that's all going to be in a bracket like this. Sorry, we forgot to write in h over 2 there at the beginning. So if we start filling this information in now then, we'll see what we get out as our answer. So the area is approximately equal to h, the distance between them is 6. So that's 6 divided by 2. Then we add the first term, y1, and the last term, yn. So that'll be 4 plus 8. We're also going to add 2 times the sum of all the in-between terms. So 6, 8, 7, and 5. So 2 times the sum of all the terms, 6 plus 8 plus 7 plus 5. Now all that we have to do to get the approximate area is just solve this out. So we can do this using a BIDMAS approach. We can try and solve what's in the brackets first. So if we simplify this most inside bracket here, 6 plus 8 is 14, plus 7 is 21, plus 5 will give us 26 for that bracket. Now BIDMAS will tell us to try and solve the next bracket out, which is this one here. So we have some addition in here and we have some multiplication. So we'll do the multiplication first again because of BIDMAS. So 2 times 26 will give us 52. Okay, and everything else just stays the same for the time being. At this point now we can probably solve out the rest of this bracket because it's just addition left inside in it. So 4 plus 8 is 12, plus 52 will give us 64. Now to solve this out finally, we can simplify the term outside the bracket and then we have to multiply it by what's inside. So 6 divided by 2 will just give us 3. So the area is approximately equal to 3 times 64. So that will give us a final answer that the area is approximately equal to 192. Now if we look back at the units we were given originally, that was centimeters. So area then must be, if it's based off that, centimeters squared. So we'll just look at a second example now that is based off some pretty similar principles. This also uses the trapezoidal rule because it's a very irregularly shaped object. But with this one, there's just a slight trick to it that I don't want you to get caught out by. So again, if we want to find the shape of this, we'll just draw some evenly spaced lines. Again, really important that the lines are evenly spaced. Normally the lines in a question will be drawn for you, so you don't need to worry too much about that. But if you are asked, just make sure that all those lines have the same distance between them. And this time we might say the distance is 4 centimeters in between each of those. Again, the exact same for each of them. So they're all 4 centimeters. Now they may also say in this question that the first height here is 12 centimeters, the second height is 10, the next one is 6, and the next one is 7. Again, it's the trapezoidal rule because it's an irregular shape object like this. So it's going to use the same formula. So again, the area is approximately equal to the distance between each line divided by 2. All multiplied by the height of the first line plus the height of the last line. It's not a very good end that I've drawn. I'll redraw that again. So that doesn't look like a 2 anymore. Then 2 times the sum of all the other terms, or all the other heights in the middle. So what's different about this one? You may have already spotted it, but you'll see when we fill it in. So the area is approximately equal to height, which is 4 divided by 2. Here's where we get to what's different. Y1, the first height here, actually is 0. There's no correct first height. So just don't be tricked by putting in 12 as the first height, because it should be where the line actually starts and then where the line actually ends for the last one. So this will be 0 and this will be 0. Then it's going to be 2 times all the other heights. So it'll be 2 times 12 plus 10 plus 6 plus 7. Again, BIDMAS tells us we should always solve the furthest inside brackets first. So that'll be this one here. So 12 plus 10 gives us 22, plus 6 gives us 28, plus 7 gives us 35. So that whole bracket simplifies to 35. Gets multiplied by 2. 0 plus 0 just cancels out. And we're going to multiply that whole thing by 4 divided by 2. Again, Biedema says we should deal with the brackets first, so we'll deal with these brackets here. So 2 times 35, solving for the larger bracket, will give us 70. And now we can multiply by the outside term, so 4 divided by 2. And the area then will approximately be equal to 4 divided by 2, which is just 2 times 70, which gives us an approximate area of 140. Again, we'll just look back at what the units given to us in the question were, and it's centimeters. So our area should be in centimeters as well, but centimeters squared for area. Now, one last type of question that I just want to draw your attention to. It's a question where they give you a completely irregular object like this. So you can see there isn't any straight line there to use the trapezoidal rule with. But that doesn't mean that you can't actually make it fit the trapezoidal rule. All you have to do is think outside the box a little bit. So if you're given a question like this, shown a piece of ripped up paper or something similar, what you would do is just draw a horizontal line across, and then you can split up the top and split up the bottom. So now actually you can use the trapezoidal rule. If you think of the top half as one object that you're trying to find the area of, the bottom half is a different object, you can use the trapezoidal rule for this section and the trapezoidal rule for this section and just add your areas together afterwards. So this area plus this area down here, you can call it area 1 and area 2. If you add them together, will give you your total area. So the total area is going to be equal to area 1 plus area 2. Now that'll be a slightly harder type of question, but I just want you to be prepared to have that trick up your sleeve when you do come across them.